During our work, my team and I interact with our customers and their installations of their distributed systems. Well, so we have some insight on what these environments look like and what are the tools for monitoring and logging. And well, I can say that there's really often a huge gap in monitoring and logging that can be easily covered by following a few straightforward steps that will help you in future work to solve your issues that can happen in your distributed environment. So I would like to cover some methods and tools for monitoring and analysis of data that is coming from your system. And we'll look into like some abstract ideas how to monitor any distributed system. And after that, we'll come to some specifics for GridGain. And at the end of the talk, we will have a live demo. So let's start with motivation and see why should we monitor our systems in the first place. Well, let's imagine that we are engineers of support and we have a customer that comes to us and he has some kind of issue. For example, his cluster is hanging and his operation are coming to cluster, but they don't get any response from it. So, so the interaction usually looks like this. It's well, first of all, we need some kind of information. So we usually start by asking for logs. So we ask, do you have any logs? And well, usually this is the kind of information that is available, but sometimes even this is not monitored and it's not available. So, well, sometimes customer says, no, we don't have any. And after that, we start looking into some other kinds of information. For example, maybe they happen to have thread dumps because it's had in operation. Maybe there is some kind of deadlock, so we ask for thread dumps. And in some cases, thread dumps are not available neither. And after that, we start guessing, well, maybe there is some kind of issue with memory consumption because, well, maybe garbage collector kicks in and stops our operations. And this kind of ping pong goes on till the point until we either have all the information needed for our analysis or any information at least, or we configure additional monitoring and after that, we wait for the issue to happen again to have all the evidence to work with. So this is the huge delay between the issue happening in your system for the first time and the solution. If you spend some time, if you invest some resources into configuring monitoring, after that it will improve your work with your distributed system. So. Let's look what we want from it, what we want from it, and what we want to see in our monitoring tools. Well, first of all, we want to have some kind of dashboard that will show a state of our system. And we would like to look at it and say if it's doing all right and if it's able to process our requests in the first place. This is a kind of indication of state of our system. And if any upcoming issues are going to happen, then we want to know about it and we want to be able to react to such kind of situations. And if something has already happened, we want to know about it because if we don't, then the situation will only get worse. And if something happened, then we want to know, we want to discover these situations, and we want to know how to react to it. This is a task for dashboarding, so a kind of a tool that will show a state of our system. And another kind of monitoring is logging. So if something has happened, you need some information about in what state was your system before this happened, what led to it, and how to prevent it from happening in the future. Maybe you have some kind of bug, so you need to collect all the evidence, and you need it to be stored somewhere. So in case if you need it, you have access to it. So let's look what are the specifics of distributed systems and what can we take into account when configuring monitoring. Well, any distributed system is a set of nodes and connections between them. So you can monitor these parts as separate parts. And also, even if your nodes and your connections between them are doing fine, it doesn't mean that user requests will be processed as they should be, because there may be some kind of issue of higher level. So you also need to monitor it as a black box. So you may look at user requests and see if they are processed correctly, and you can also create some synthetic requests. So the black box approach needs also to be taken. Now let's look what our nodes are like and what are the levels that we need to monitor. Well, at the bottom level there is hardware or hypervisor if you work in a virtualized environment or it's like some cloud. On top of it there is an operating system. Well, usually monitoring starts with this point. And on top of operating system, there is a virtual machine. Well, sometimes you don't have it, but nowadays almost any application has a virtual machine of some kind. It's JVM, .NET, Python, or something. And on top of things, there's an application. So the point is, if you have anything going wrong on the bottom level, there is no chance that anything will work on the application level. So you need to make sure that everything is working fine on every level, that resources are available for the higher levels. And I would like also to include the network, the connections to the hardware or to operating system, because it's usually monitored on this level. And the black box approach is taken on the application level. So let's go through these points and see how we're going to monitor them and what kind of information we can get from these levels. Hardware can give us the resources like CPU, memory, disk, and this is the basis of your system, and you need to make sure that you have enough of these resources and they're available for higher levels. This is the thing that you need to monitor on any setup, and it's always useful. And if something goes wrong, in some cases, system logs or cloud provider logs can also be helpful. So make sure that you have it and you know where they are. And if anything goes wrong, you have access to this kind of information. Well, in our practice, we had a case when we saw a Java application working, and it looked like it had all the resources available because garbage collector didn't kick in too often. But at some point, we saw that the Java application quit, and it didn't even finish the log line. So it just was interrupted in the middle. And the answer was in the system logs of out-of-memory killer. And we saw that at some point the system decided that it didn't have enough of resources, and the out-of-memory killer just decided to kill the process. And that was the answer, and we found it on the operating system level. So this kind of information sometimes is useful. Well, network is also a basis of your system, and if it doesn't work, then you won't have any distributed system. So you can perform different kinds of monitoring here. You can, for example, set up a set of agents that will look after each other and tell you when some connection between nodes is not working fine. So it can send pin requests between the agents and see if they are processed fine. And if there is some kind of delay, you will see it. Another kind of approach here is monitoring of your network hardware. If you control it and if it's your environment, you can see if the switches, routers, hubs are working, and if something goes wrong, you can somehow fix this kind of issue. And well, if you learned how to reproduce your issue and you're looking into the reasons for it, you can take a TCP dump and look what kind of data is sent between nodes. It's kind of hard to look into this kind of information, but the advantage here is that you don't need to add any code to your system, and you can just attach to a running system and see what data is sent between nodes, and you will see what happens there. And sometimes we use it for performance debugging, and if we want to see separation between stages of processing our requests, then we can see take a TCP dump and see what is the difference between timestamps of request coming to the server and response sent back. So this difference will show us how much time is spent on the server side. And well, sometimes we take this approach, and TCP dumps are may be helpful here. Well, on top of operating system, there's a JVM and or any other virtual machine, and any VM has a set of processes that affect work of your application. So you also need to take it into account. And also, out of the box, many virtual machines have a lot of metrics available, so you just need to apply proper tools to get this information. For example, any virtual machine has a garbage collector. Well, most of them do. And garbage collection is a situation where your application stops for some time if it's stop the world GC, and during this period the app is not able to respond to any request. So this case really looks like a network issue. And to understand what case is it a garbage collection or it's a network, you're going to need to configure GC logs, because this information is available here. Also, for JVM at least, there is an interface called Java Management Extensions, or JMX, and out of the box you can get a lot of information about your virtual machine, like consumed memory, loaded classes, how many threads you have, in what state they are, and all this information. Well, in some cases it may be useful, and you don't need to configure it in any way. It's just available out of the box. Other things are useful if you learn to reproduce the issue and you want to learn the reason for it. For example, if you need to learn about reasons for some performance issues, you can go to Java Flight Recorder, which is available out of the box in Oracle JDK till 11, or from 11 it's available in any JDK, so you can just use it, and it's a really useful thing. It has a lot of information available, like hot methods, allocation rate of objects, and it's a snapshot of operations that happen during some time period in your system. It has some overhead, but for some short time period you can take this kind of snapshot and you will see what happens in your system. Also, thread dumps to look into deadlocks, or heap dumps to look into memory leaks are useful here. For heap dumps, well, usually if you have a memory leak, at some point you're going to have an out of memory, well, in most cases, and in this case the heap dump is the most useful part of the information. So customers come to us and they say, well, we have an out of memory, and well, we say, oh, okay, send us a heap dump. But when your system has already quit, you don't have access to any data about your heap. So we recommend configuring this flag heap dump and out of memory. So if something bad happens next time, we are going to have every evidence. So it's access to it before anything bad happens. So it's better to do before something goes wrong. And on top of things, there is an application that knows the best about what happens inside it, and it can tell when anything goes wrong. The most useful part of information about your system is stored in application logs. So please make sure that you have it available and enabled and configured on the proper level, because without it, nobody can perform any kind of analysis. Even if you have your own engineers, they're going to need them to figure out what's happening in your system. Also, you can use the same interface that you use for JVM. Well, your application can also use JMX to expose any metrics for analysis using the same tools and interface that you can use for JVM. If you want to take the black box approach, you can look into how many requests are processed during some time span, or how much time is spent for every request. So you can look at throughput and latency of user requests, or you can also send some synthetic requests and test queries that you'll see if they are processed fine and if the results are correct. So this is a kind of approach that can be taken here. So to this point, we have reviewed some abstract ideas and the kinds of information that you can collect from your system. So let's now review some tools that you can use for its analysis. Let's start with metrics and time series. Here, usually the pair of Prometheus and Grafana is used. Here, the Prometheus is the data storing level that is used for collecting metrics and giving it to Grafana. And Grafana is used for creating plots and indicators, and it's pretty flexible, so you can configure, for example, your information of resources, and you can collect information from every level and build some kind of dashboard here, and it will work as an indicator of leavings of your system. For text, or for example for logs, usually Elasticsearch, Logstash, and Kibana are used, or ELK. Or also you can use Splunk as an enterprise analog. This is more convenient than just using text files and analyzing this kind of information by hand, because you can do real-time analysis of your logs. You can get some information from text and build plots, for example, and it can be done in runtime, and you don't need to wait for something to happen to look into logs. You can do it just on the fly, and it's more just convenient than performing some manual monitoring of logs. And you can have some centralized location when all of the nodes are writing information about your system, and you can analyze this in one centralized place. And for any virtual machine, there is a special set of tools. I already mentioned the Java Flight Recorder as a profiler. You can use any analog, for example, Visual VM. And inside GridGain, we don't usually use Visual VM, but it's a pretty useful tool and pretty popular, so you may want to learn about it. For garbage collector logs, there is also a set of tools that can be used. It can parse your logs and build plots memory consumption levels and GC poses, and it's more convenient than just looking into the text and trying to figure out what's going with your GC. You can use, for example, GC Easy website that can build this kind of visual information about your GC based on garbage collector logs. And for heap dumps, we usually use Eclipse memory analyzer tool called MAT that can perform some basic analysis. For example, it can build a dominated tree and show some leak suspects, and you will know well, where to look if you have any memory leak. So it's also pretty cool stuff. For network, there is a special set of tools, and for example, Zabbix can be used to monitor your hardware, network hardware. It can set up a set of agents that will collect your data, and you can configure alerting based on this information. Zabbix can be also used to collect any kind of data, not only about network, but usually it's applied for network. Also, if you know what kind of vendor of your network hardware is, you can go to this vendor and ask for tooling. For example, if you have Cisco, it has a lot of tools for its monitoring and troubleshooting, so you can just make use of it. SolarWinds is another tool that can set up pin monitoring. You can set up a set of agents that will pin each other and tell you when something goes wrong. And for TCP dumps, we usually use Wireshark. Also, I would like to mention benchmarking. GridGain, at least, usually is benchmarked using Yardstick, JMeter, or Kotlin. And the most popular one is JMeter, but in some cases it shows you not what you want to see. Well, sometimes we notice that benchmarking using JMeter looks like you have JMeter that sends requests to your web server that proxies request to your application. And sometimes we saw that the performance is not that good, it's not what we expect, and we tried just removing all the business logic from our requests. And we saw that performance didn't change, it stayed approximately the same. And turned out that the bottleneck was in the web server. And this is a pretty popular pattern for benchmarking using JMeter. Sometimes it's fine, but you need to make sure that the bottleneck is where it's supposed to be. Yardstick is a tool that was developed inside GridGain, and it's developed specifically for benchmarking of distributed systems. It has a set of tools for like setting up your distributed system, warming it up, running the benchmarks, and building a report. You can collect data from different nodes. For example, this report has throughput and latency plots, and also you can include information about memory, CPU, and disk consumptions, and you can include all this information averaged for every node into the same report. For example, on this plot, it's throughput for get benchmark, and we can see that there is some kind of issue with garbage collection, and we should probably configure some garbage collection here because there were 3 stops. Well, to this point, we have reviewed some tools that can be used for any distributed systems. Now let's see what specifics GridGain has and what can we take into account to configure monitoring specifically for it. Well, GridGain is just like any Java application, has the same levels like hardware, OS, JVM. So everything that I have said before this can be applied for it. But the difference is on the highest level, and we should just take into account the specific processes that happen inside GridGain and the resources that it needs. GridGain is a data storage, so it works with, first of all, memory and CPU. Also, it works with disk, and like any distributed system, it needs network. So the same approaches also are applied here, but we can look into the specific processes that happen inside GridGain. For example, the basic like entity of GridGain is a cache, and we have a set of metrics for performance of caches. For example, you can see the latency and throughput of these operations. And one important process related to caches is rebalancing. If you have any rebalancing happening in your system, it may be not safe to perform any restarts of nodes, or maybe it can lead to some issues with the performance. So if it's really the case, you can see it using this metrics available in JMX. This kind of metrics can be enabled in configuration using this property, or it can be enabled in JMX, so you can do it in runtime. The information about rebalancing is available without any additional configuration. It's always there. Also, network can be monitored on the application level, because we have two kinds of transport. It's discovery and communication, and each of them has its own set of metrics, and you can look at network on the application level, on the transport level. Discovery metrics are the most useful ones here, because you can learn a number of messages and queues, and if you see that these queues are too big, then it may be some kind of issue in their processing, and you can see how long they're processed, and other kind of information, how much data is sent between nodes, and you can get some. If you can correlate your issues on the user level with this kind of information, and in most cases it's pretty useful. GridGain, starting with version 8, has a persistent data storage capability that enables you to store more data than you have memory available. So if you have all the operations go through disk, and if something goes wrong, you have all the information available on disk, and it's useful for failover. So you have some subset of data in memory and the whole set of data on disk, and there is also write-ahead log, which is used for failover. So if something goes wrong, we recover from write-ahead log. And for data storage, we also have specific set of metrics. For example, you can learn about data volume that is used for different kinds of data in data storage. For example, you can see how much the write-ahead log is taken, or you can see how much off heap is used. And for every data region, you can also learn this kind of stuff, and see how many pages are allocated for this specific data region, and what is the allocation rate, and what is the page fill factor for this data region. So it's pretty useful. Also, there is a set of specific processes that are related to data storage. For example, there are checkpoints that can affect work of your application in terms of performance, because the operations may be processed not as fast as when checkpoints don't happen. And for it, you can track it. You can make sure that the checkpoints don't happen too often, and they don't take too much time, and you can track it using this set of metrics. Like you can see how many dirty pages is the ones that are marked as changed, starting from last checkpoint, and you can see how long it usually takes, and well, stuff like this. And page replacement is another process that affects your application, and it's a situation when you have some operation that needs to be done on the page which is currently on disk. And to do this, you first need to read this page to memory. And in some cases, when you don't have enough memory, then you need to remove one page and put another one in this place. And if you have this process happening too often, then it means that bottleneck will be on disk, and it's much slower than the new memory, and you're going to have like issues with performance. So you can also track this process and see if any issues are there related to page replacement. This kinds of metrics can be enabled in configuration and also for in JMX, and you can enable it in runtime as well. For Ignite version 2.8, there is a set of metrics added additionally, and it's planned for release soon. It's logical and physical reads. And you can see what is the fraction of logical reads in your system that had to go to disk and perform some write or read operation on disk. So if you need to bring some data from disk to memory, you will see this in this metrics, and also information about indexes. How often do indexes are indexes used? So you can see if you see that a lot of reads go to disk, then you may have some kind of misconfiguration, and the bad performance may be caused by this. And for GridGain, we have a tool WebConsole that can be used for some basic dashboarding and management. So you can just set up a WebConsole, and it will show you a state. It has a set of dashboards and plots and indicators that show the state of your system, and you almost don't need to perform any configuration. It's just available out of the box, and you can set up your cluster and run a web agent that will connect your cluster to a web console, and it doesn't have to be in your environment. You can connect your cluster to, for example, web console, which is running on our website console.gridgain.com, and you'll go to our website and you'll see the state of your cluster. So you'll be able to monitor it even remotely. Let's now take a look at some demo of tools that can be used for monitoring GridGain. Well, I prepared a cluster of 3 nodes. They are running locally on my machine, and they don't have any specific configuration, just data regions with persistence enabled, and some metrics for data storage and caches, and also there is a web agent running, and it connects my cluster to web console, which is running in console GridGain.com. Also, there is one interesting thing. The logger is configured that way that it doesn't write logs to files, but instead it sends information to Logstash that stores information to Elasticsearch, so you can look at this information in Kibana. So the log4j2 can be configured that way that you will have information in Logstash and Elasticsearch. Web console on the idle cluster look like this. You can see that the cluster is inactive at this point, and let's activate the cluster. After that, we will be able to work with the cluster and perform some operations. we would like to see some activity in our cluster, so I also prepared an application that performs computation on our cluster. It calculates a number of divisors of numbers starting from 1 till infinity, and it splits all the work, spreads the work to all the nodes in the cluster, and it calculates the result, and after that stores the result into cache. So we have work with computation and with caches, and also persistence is enabled, so work with disk is also happening. So let's start our application and see what will change in WebConsole. So we see that the work has started, and we already have some results. And we see that, well, CPU increased, and memory goes up, and we see some metrics for caches, for throughput and latency, and also cache size has increased. And well, we have like some basic dashboards for seeing information about our cluster, like about resources and processes that happen in our cluster. Also, there is information about nodes available. We can see that there are 3 server nodes and 1 client which is running the computation. And we can see their consistent IDs, their IP addresses, their version, and stuff like this. And after that goes information about data storage. So for every data region, you can see how much data is stored there, and how many pages you have there, and something like this. Well, and for cache, you can see how many like primary and backup entries there are, and and other information related to caches. Let's go to baseline topology tab. Here there is indication of your current baseline, and you can perform some management on it. For example, we can stop one of the nodes, and we will see it. Oh, I logged out. Oh, I don't remember the password, of course. Okay, we're back. So here we can see that one of the nodes is offline, but it's still in the baseline. And it means that the 2 nodes that are left are not performing in any kind of rebalancing, so the data is stored there, and the backup factor is not restored, because there is 1 node which is still in the baseline, and it means that it's supposed to come back soon. If we don't expect it to be back, we can remove it from the baseline and perform this change, and we will see that well, in a while it's removed from a baseline, and now we have only 2 nodes here. So this is kind of management that you can perform here. And after that, there go a set of tools that are available for our enterprise features. For example, rolling upgrade. You can see the set of nodes in our cluster, and their state, their version, and uptime, and if any rebalancing is happening. So if you perform rolling upgrade, which is done usually on nodes 1 by 1, you restart 1 node and update its version, and after that you go to another node, and this kind of dashboard is useful to see if you have any activity happening in your cluster, so you don't break anything by restarting your nodes. Well, after that go data center application and snapshot tabs, but well, I didn't configure any of this. Well, we also have a set of plots for it and management tools, but it's available only in Enterprise and Ultimate editions. I started open source Apache Ignite and connected it to console GridGain.com, so you can also do this. It's available for free, so go and you can go and try it. Well, in Kibana, we have information sent from our nodes, and here we see that the first node that we stopped doesn't write anything to log for 3 minutes, but we can switch to another one and see logs coming from this node, and you can perform some filtering. For example, if you want to learn about information about topology, you can look for it. And you can see the history of changing of topologies that we had when topology changes happened and what happened during this period. Or, for example, if you're interested in activity of some specific thread, you can go to it and see the activity related to this specific thread. And it's more convenient than just parsing logs, because the analysis here happens on a record basis. So every record is analyzed opposed to every line. So if you have some information in a record, you can filter it out, and all the lines will be affected. So let's get back to slides and have some summary. We have seen that the important part of monitoring is making sure that you have enough resources. So CPU, memory, disk, network is the basis of your distributed system, and if you don't have them if you don't have enough of them, then you're going to have problems on high levels. Also, garbage collector logs is almost always useful in any kind of analysis, so make sure that you have it available, and we recommend to enable it in any production system because it doesn't have almost any overhead, and it's really useful. And also, of course, application logs contains a lot of useful information that you are going to need. Also, if you have any problematic place that you expect issues coming from it, then spend some time and configure additional monitoring for it. For example, if you know that your network is not that reliable, then you may need to spend some time and invest resources into configuring monitoring for it. You can see here links to console GridGain.com website where you can set the monitoring for your cluster, including Apache Ignite, and link to my GitHub repository where you can find a Docker container with pre-configured Elasticsearch, Logstash, and Kibana that takes into account specifics of Ignite, so it can parse logs of Ignite, and you will see it in Kibana. So now I'm ready to answer your questions.
Do you know about the impact for performance when you turn on the console?
For WebConsole, I don't think we have. Usually the impact is coming from some metrics that you enable in your cluster. For example, if you enable cache metrics, it has some overhead. You can see it in your performance. But the WebConsole on itself, it doesn't really have any overhead.
So then why it turned off by default?
Turned off?
I guess you need to turn it off on in configuration, no?
What, WebConsole, you mean?
Yeah.
Well, for WebConsole, you need to additionally run a web agent that will connect to your cluster. And, it's an additional kind of configuration. Not everybody wants to use WebConsole, and it's kind of additional steps that need to be taken because, it's WebConsole on itself needs to be run somewhere. And, we usually don't do it right in the place where WebConsole is run, but it's some kind of a separate node that runs the WebConsole. So it's.
And as I understand, you have you previously in of tools for monitoring, and right now you almost migrated all of them to WebConsole, right?
Yeah, we had previously a tool called Visor, and it had some management and monitoring tools. And now I think all of it is covered in a web console. We find it more like useful than the desktop application, because not in every environment the desktop is available. So you can't run UI on your production. It's not always available, but.
Does it mean that some Visor will be deprecated in some future?
Yeah, I think so. I think we have already deprecated it, and it's planned for removal.
Okay, so there is no development for this, right? Only for new features will be available only in console.
Yeah. Yep. Yep.
You mentioned TCP dump and Wireshark.
Mm-hmm.
Thinking about GridGain specifically, you guys will actually look at TCP dumps, and then I assume in that case we need to be thinking about TLS keys, because we've just got a dump that's not that good.
You mean disabled TLS?
Well, either disabling or management keys in such a way that we have them.
Well, usually we analyze TCP dumps when no encryption is enabled for a node. So we didn't have a case when we had to look into TCP dumps when TLS is enabled, but I think it's also possible.
You said that Visor is deprecated and now we need to switch to the web console, but in the past the web console didn't offer any LDAP integration, so no authentication, no authorization on our side. We need to rely on.
Well, at this point, I think LDAP is supported, so we implemented all the features that are available in Visor. They are always available in web console. So now, if we plan to implement new features for monitoring, we do it in web console. So we don't improve Visor any. We do it in web console. We don't improve Visor any further. We only provide builds with it, and that's all. Yep.
Anything around monitoring compute tasks or on the way?
For compute tasks, web console has it. It has a view on how many compute tasks you have run, and what compute jobs are started by every compute task, and stuff like this. How much time is spent for every compute task. So it's also on the monitoring.
Does that have to be enabled like that?
Yeah, you have to enable event storage API and enable the switch in the web console.
So what's the largest cluster you have been able to monitor with web console?
With web console, well, I don't think I have this kind of information, but usually it's a couple dozens of nodes, so it's 10 or 20. It's a usual setup, and so it's not a matter of size of your cluster. It's kind of. I think the bottleneck won't be here. Won't be in a web console when you set up a cluster this huge.
So if I have a 128, 200 node cluster with 3,000 caches in it, it can cope with it?
Yeah.
My question about GMX metrics,
Mm-hmm.
performance overhead. So, how much is this overhead? Is it like a good idea just to enable them in production? Do you know?
For every metric, for every kind of metric, there is overhead. For example, the biggest one is for caches that I know, because the sizes of your discovery messages will increase, and it will increase time of processing of these messages. So you may want to enable cache metrics for only part of your caches, and that are key caches in your system. So for data storage, and I don't think that we have any kind of overhead for it because they all are local and they're just stored on the
Yeah,
nodes.
so this is the second question about always metrics and GMX are local, yes? I mean, for example, cache statistics.
Mhm.
Are they for unit together than for every single node, or are they aggregated?
Metrics for caches are like cluster-wide, so you can enable it for a cache, not for a node. It's for a cache. But for data regions, the data region is an entity that makes sense only on a single node. So you can enable it on every node separately. So yeah.
And lastly, are these, I can configure them at runtime?
These metrics can be enabled in runtime. Also for data storage, you can also, using JMX, enable them, so they are available. So I think we're running out of time. So if you have any questions, I'll be here till the end of the day. So feel free to come and ask any questions. Thank you.